Today, we're breaking down some of the most useful math shortcuts you'll ever learn. Divisibility rules. These rules let you check whether a number is divisible by 2, 3, 5, 7, or 11 without doing long division. A number is divisible by 2 if its last digit is even. That means the final digit is 0, 2, 4, 6, or 8. For example, 246 ends in 6, so it's divisible by 2. But 151 ends in 1, so it's not divisible by 2. A number is divisible by 3 if the sum of its digits is divisible by 3. For example, 372 becomes 3 plus 7 plus 2, which equals 12, and 12 is divisible by 3, so 372 is also. But 205 becomes 2 plus 0 plus 5, which equals 7, and 7 is not divisible by 3. A number is divisible by 5 if it ends in 0 or 5. For example, 1,450 ends in 0 and 935 ends in 5, so both are divisible by 5. But 472 ends in 2, so it's not divisible by 5. The rule for 7 is a little trickier. Take the last digit, double it, and subtract that value from the rest of the number. If the result is divisible by 7, then the original number is divisible by 7. For example, with 203, the last digit is 3, doubled is 6, and 20 minus 6 equals 14. 14 is divisible by 7, so 203 is also. Another example is 259. The last digit is 9, doubled is 18, and 25 minus 18 equals 7, which is divisible by 7, so 259 is also. A number is divisible by 11 if the difference between the sum of its alternating digits is 0 or a multiple of 11. For example, with 462, add the first and third digits to get 4 plus 2 equals 6. Then compare it to the middle digit, which is 6. 6 minus 6 equals 0, so 462 is divisible by 11. But with 91827, adding every other digit gives 9 plus 8 plus 7 equals 24, and the remaining digits add up to 1 plus 2 equals 3. The difference is 24 minus 3 equals 21, which is not divisible by 11. And that's it. You now know the quick divisibility tests for 2, 3, 5, 7, and 11. These shortcuts save time, reduce mistakes, and make mental math much easier. If you want more simple math explanations and problem-solving tips, keep learning with Online Tutor House.
All right, we're going to go ahead and do prime factorization level 1. Level 1 just means that we have exactly two factors that make up this composite number that we want to find. So in order to find them, we are going to need to use our divisibility rules, okay? And so as we go along, I'm going to remind you what those divisibility rules are. Firstly, we start out with 2. As soon as you look at the number, you're going to determine whether or not that number is even or odd, right? If it's even, you know one of the factors is 2. So if it ends in 0, 2, 4, 6, or 8, you know that that very first bubble is 2. So since 106 is even, we're going to put 2 here. And then we'll take half of 106. Half of 10 is 5. And half of 6 is 3. All right, then the next one, we're going to use, since it's odd number, the next thing we're going to check is divisibility for 3. And we sum up the digits, 1 plus 1 plus 1, which is 3. So since the sum of the digits is a multiple of 3, the whole number itself, 111, is a multiple of 3. So we can say it's 3 times something, and we'll just say how many 3's we can put in 11. We can put in 3 of them. That's 9, and then we're left with 2 and 1, 21. So we have 7, and that checks out because that's a prime number. All right, so the next one we have here is the divisibility rule for 5. All it says that if the number ends in 0 or 5, one of the factors is 5, so that means it's a multiple of 5. Okay, so since it ends in 5, we know one of the factors is 5, and then we can fit 2 groups of 5 in 11, leaving 1 left, and 1 and 5 make 15, and there's 3 groups of 5 and 15. So that gives us 5 times 23, 115. Next, we have an even one, so we know one of the factors is 2. Half of 118 is going to be 5 and 9. Okay, we can keep on going. 119, it is an odd number. And let's see, let's add up the digits. Since it's not even, say 1 plus 1 plus 9. Oh, well, that's 11. So it's not even a fact or a multiple of 3. It doesn't end in 5, so it's not a multiple of 5 either. So we're going to pull out our 7, our 7 divisibility rule, and it says that we'll just double the last digit and subtract that product from the remaining digits and see if we get a multiple of 7. So 9 plus 9 is 18. So 9 times 2, that's 18. 18 from 11, that gives us -7. So since that's a multiple of 7, one of the factors is 7. Okay, we can put one group of 7 and 11, leaving us 2. No, sorry. Leaving us 4, 49. 7 is 7. So 7 times 17 is 119. Okay, very good. Let's go ahead and go on to the next one. It says 1 plus 2 is 3. 3 plus 1. Once again, it is not um it's not one of the factors. And it's not even a factor of 7 because 1 times 2 is 2. 2 from 12 is 10. So that's not a multiple of 7. So 7 is not it. So our next prime possible factor is 11. Okay. So 11 divisibility rule says we take the alternating and we see if the difference between the sum of the alternating gives us 0 or a multiple of 11. So 1 plus 1 is 2. 2 minus 2 gives us 0. So yeah, we can do that for 11. And it just so happens that 121 is 11 times 11. So it's actually a perfect square. You may have already known that 121 was 11 times 11. So forgive me, I'm not trying to insult your intelligence. I just want to go ahead and do the rules of divisibility so that you know them. Okay. All right. The next one is 2 plus 2 plus 1. Oh, no, this is even. So 2 is one of the factors and 61 is the other factor. Next, 3 plus 2 plus 1, that's 6. So one of the factors is 3. And then the other factor is going to be 41. All right. Next, 129. Well, one of the factors has got to be 3 since that's 11 plus 1 is 12, and that's a factor of 3. So the other factor is 43. Okay, next we have another odd one, but it's not divisible by 3, right? Because the sum is not a multiple of 3. Okay, so we're going to go on to 7. Well, because it doesn't end in 5, so or 0, so we know it's not 5. So we go to 7. So the divisibility rule for 7 says that we double the last digit, so 3 times 2 is 6, and we subtract it from the remaining digits. 13 minus 6 gives us 7. So, yep, that is a multiple of 7. So one group of 7 can fit into 13 once. And then what's remaining is 63. That's 9. So it's 7 times 19. Okay, next we have an even one. So automatically that's 2. And then 6 groups of 2 is 12. 12 from 13 gives us 1. 1 and 4 is 7. So 2 times 7 gives us 134. All right, 141 is odd. So, let's see. Oh, 1 plus 4 plus 1 is 6. So that's good. And we know that one of the factors is 3. And so how many groups of 3 fit in 14? Well, we have 4. And then 12 from 14 is 2. 21 gives us 7 groups of 3. So we have 3 times 47. Okay, next is an even one. So we know one of the factors is 2. Let's look at the divisibility rule here. 7, 8. Nope, that's not by 3. So 6 from it gives us 8. And so that's not right. So it looks like the alternating will work. 1 plus 3 is 4. 4 minus 4 is 0. So we know it's divisible by 11. But what's the other factor? I'm going to let you figure that one out. This ends in 5, so one of the factors is 5. I'll let you figure out the other factor. And lastly, this ends with 6, so one of the factors is 2. Go ahead and finish that. You can put your answers in the comment box.